Hello everyone, this is Hüseyin Bekçi. I'm working as project coordinator in R&D department of IGDAŞ. First of all, I would like to thank the Eurasian Scientech is organizing this annual international conference for giving me the opportunity to present our study. Let me start with brief information about IGDAŞ. IGDAŞ, with 6.5 million subscribers, the largest in Turkey, is one of the Europe and world's leading natural gas distribution company. And in the context of R&D projects and field operations, we have experience in smart gas meters, smart grid, and ICT application in the natural gas network. And IGDAŞ has been maintaining gas distribution service in Istanbul for 35 years by increasing its service quality. And let me introduce myself. I completed my undergraduate education in Istanbul Technical University, Petroleum and Natural Gas Engineering Department, and I completed my master degree in Istanbul University, Department of Industrial and System Engineering, with the thesis on smart grid maturity level analysis of natural gas distribution in big cities case study for Istanbul. And I'm ongoing doctorate education in Marmara University Industrial Engineering program, and I have been working in different projects in information system trades and R&D and strategy department for the last 3 years as a project coordinator. And additionally, we are realizing this study within the scope of ongoing AI semicode project, which is funded by TÜBİTAK and Eurasia. And the name of our study determines smart gas meters, qualifications, and life cycle by using QFD analysis. And here's agenda. I have already given brief information about the study and this project by analyzing the collected data from smart gas meters. We carry out studies that will create value for company in the areas of loss application detection, operational efficiency, and daily consumption estimation. Thus, the smart gas meter have an important role to establish decision support system will serve our company, and I will give information about the literature review, methodology, and the results of study. Actually, there is no study intended to address the quality evaluation of smart gas meters privately in the literature. And we have listed here QFD analysis studies from related areas, the limited number of studies which combines QFD with other methods in the field of especially energy and other areas is presented here. And you can see the studies which combine QFD and other methods on the left side, and you can see the studies which using only QFD methods on the right side. As you can see, there are a lot of application area and application perspective, because we can use QFD to enhance any product or process or company. There are a lot of alternatives for using QFD. And our motivation, I want to give an example here. Some researchers use QFD in examination of quantitative models of sustainability liquefied natural gas supply chain management, and you can see this study in here. Our motivation in this study, the evaluation process has been investigated for the technical features that have been considered in smart meter procurement. This study aims to perform a systematic ranking and the selection of the best smart gas meter alternatives, meeting the necessity of distribution system operators as per the determined criteria mentioned above. The aim of the paper is to determine the criteria for a special smart gas meter by using quality function deployment technique for the natural gas sector in Turkey. QFD technique was selected for the product enhancement operation in Igdaş, and the three specialists provided their evaluations of the criteria. The implementation of QFD in smart gas meters is defined systematically. To best of my knowledge, there is no any uh, study about smart gas meters in the literature. Yeah, as you see, QFD is designed by Yuji Akao in Japan. QFD analysis is preferred as a convenient tool not only for new product development, but also for the improvement of a product with different versions and approach in various areas. Within the scope of the project carried out in English, the QFD methodology was chosen to determine the product features to be preferred. Experts were selected to improve smart gas meters thanks to QFD. Smart gas meters are used in households to measure gas flow and to manage some operations. The implementation QFD to the smart gas meter is explained step by step as follows. Step 1. User prospects were specified by questionnaires by quality control and R&D and field personnel. User expectation and rated out of 9. And step 2, technical requirements relevant to user expectation are specified and stated. Technical requirements for QFD analysis are significant as experts take these requirements into account to meet user expectations. And technical requirements described in this work: measurement accuracy, abnormality detection rate, lifetime, assembly and preparation time, cost, failure rate per batch, lifetime, MIDC and EMP, compliance-related IP, and the measurement capability for 30% hydrogen blending. And step 3, within the scope of the study, after specifying the technical requirements, the expert at Dash established the relationships between user expectations and technical requirements. Significance and direction of improvement are other important issues in QFD analysis. As you see in the table 3, interrelations between the customer expectation and technical requirements are evaluated with the 9, 3, and 1, strong, moderate, and weak relationships, respectively. The degree of difficulty represents the level of applicability of each technical requirements, and the end of the table relationships between user expectation and technical necessities are presented. Also, the technical properties and normalization value is calculated at in the study. And step 4, the significance value of each technical requirement is figured out using equation 1, and the normalization rate and of each technical necessity is calculated with equation 2, as you see this equation on the screen. And step 5, correlations among technical relevances are defined. As you see, some customer expectations and technical requirements have positive and strong relationships, but the others have negative interrelationships, and the other none any. There is not any relationships between some customer expectation and technical requirements. What are the results? It has been determined that elimination of any measurement errors is the most important technical requirement, and it remains at the forefront for the following process. One of the most important results of this study is related to failure rate per batch, and it has 114 points in the weight importance. It is revealed that failure rate per batch is second important issue. According to experts in the quality improvement plan, it was determined that the most important issues was the failure rate per batch. And MIDC compliance and cost criteria are the other significant features found as significant technical requirements. The core of these two features is 90 and after the measurement accuracy and failure rate per batch. Therefore, the cost of technical requirements should be considered. In other words, the cost is another competitive area for the product. Abnormality detection rate must be considered to determine the next improvement area because of 81 points in importance weight. Thus, the alarms generated by smart gas meters are another important issue for gas distribution companies. However, the least important quality requirement is found as assembly and preparation time. Uh, what is the further studies? It has been determined that fuzzy QFD can be done in order to bring further levels of studies. The results of study have been a guide to gas distribution companies about what should be considered in the determination of technical requirements before procurement. These proposed studies will ensure regular improvement of the existing smart gas meters, and it will be contribute to coordination of integration and compatible information for process of smart gas meters. Thank you for your interest. See you later.